So in SQL, we have the query language, where if you remember that in the last lecture, we created a table and we tried to insert some column in that table. So that was the query language in which we study how we can create a table in Oracle and we can insert the data. So a relational database means where the data is stored in the tables or in the form of relations. We have tables that are linked with each other through keys. It can be the foreign key or it can be the primary. So as the name suggests, relational database means that each and every table have a specific relation with each other. It can be through different keys. It can be through foreign keys. It can be through primary keys. Then we have a third type of database, that is the NoSQL database. Mostly MongoDB is the example of it, that can be unstructured or that contains the semi structured value. Here what we have the column families, means we have the storage for the analytical purpose, and mostly the data is stored in the form of nodes. We have another type of NoSQL database, that is the graphs. For example, we have Neo4j, like it will store the data in the form of nodes and edges. So if we compare SQL versus non-SQL approach, now the SQL is the schema based. Means here we have the strong consistency constraints. We have the non-SQL approach. We have the base models. Means we have the on the basis of scalability we mostly use. So the best example of NoSQL is the MongoDB, that is mostly used in the Marin stack work. Now we have different types of relations. In relational database, I told you that one table is connected with the other table by through different relations. So we have one-to-one relation, we have one-to-many and many-to-many. Examples. So we have three types of relationships in relational database. The first one is the unary relationship, then the second one is the binary, and the third one is the ternary relationship. So what is a unary relationship? A relationship that is established with the table itself. Like we have a table person, then the table person creates a relationship with the person. Like a person lives with the person. Like the above relationship means that a person is living with another person. So such kind of relationship is a unary. Like a teacher works with other teachers in an institute. So teacher is a table, or you can say it can be an entity that works with the same person with that quality or with that qualification. That person is also a teacher and the other person is also a teacher. So a relationship that forms with the same type of entity or same type of table is the our unary relationship. Then we have the binary relationship. In binary relationship, we have different variants or we have different types. We have one-to-one, one-to-many, many-to-many relationship. So what does it mean? Like for each and every class or table, we have a relationship with the other class. Like let's suppose we have two entities. We have a chairman and a department. So what is the relationship between a chairman and a department? A chairman runs the department. So runs is the relationship between them. So what does the one-to-one means? That for only one department, we have only one chairman, or for or only one chairman can only runs one department. So that is a one-to-one relationship. Means one person holds one relationship with the other team. Like you might know that if we take another example of one-to-one relationship, at a single time, you can study one book. And that book that you are studying cannot be studied another student at the same time. Means you have your own book, you have purchased a specific book. At a specific time, you can study that. And while you are studying that book, no one else can read that because you are using that book. So that is a one-to-one relationship. You read a book currently, and that book currently can be read by you only. So such type of relationship is known as the binary one-to-one relationship. Now, we have a second type of binary relationship, that is one to many. Means one table can have many relations with the other table. Like you might know that we have state, okay? That one state can have many cities, but one city can be belong to that state. For example, we have a specific state and that state contains 20 cities. Now, in that 20 cities, only that specific city is in that state. No other state contains that same city. Like we have the duplicate names. Two or three people have the common name. But here the thing is, the state that holds that city, no other state can have that city. So it means that one state can have many cities, but one city can belong to one state only. So that is the one to many relationship. Then we have another type of relationship. Let's take another example. One college can have multiple departments, but one department can holds or contains in one college. Let's suppose in your college, or if we talk about in any university or institute, we have only one IT department. We have only one English department. A college can have multiple departments like maths, English, Urdu, physics, CS, IT, SC, multiple. But each department can be only in one college. We cannot have two or three same departments in that college. We have only one English department, we have only one maths department and others, but their quantity is one. So it means that one college can have many departments, but only one department can belongs to one college. So that is the one to many relationship. Now, if we take another example, like our employer can have many employees, okay? But currently, one employer can works in a specific organization at a specific time. So that is a one to many relationship. Now we have another type of relationship, that is many to many. Means for each instance in the first class or first table can have many instance in the second class or in the second table. Means on the both sides we have multiple instances or relationship with the other table. Like for example, here we have students and courses. Now as a student, currently you are studying multiple courses. And when you are taking your class, not only there are multiple students that also take that course. So that is the example of many to many. Means many students can study the same course and the same course can be studied by many students. Then we have another example, the employee and the skills. A specific employee can learn many skills. Like let's suppose you learn graphic design. Now you are not only a graphic designer. There can be many employees that also learn graphic designing. So a skill, many skills can be learned by many employees and many employees can also learn that specific skills. So that is the example of many to many relationship. Now we have another type of relationship in the databases, that is ternary. Now in binary, we discussed that we have two tables or two classes that are interacted or related with each other. But in the ternary, at the same time, we have the three classes that are interacted with each other. Like we have a class consultant, we have a class contract here, and we have a class or table client here. So somehow these three are interacted or related to with each other. Like the consultants can sign the contract, or then the similar client can assign that or sign that contract. So we have another example, like we have an analyst, we have a programmer, both of them work on a same project. Now project is another type of entity or table, analyst is a holds another table, and the programmer have its own entity. So somehow these three persons are related with each other. So this is the example of ternary relationship, that how the three entities are related with each other. Study in constraints. We have interrogatory constraints that we are going to study, that we must apply on our DBMs. So let's study about that. First of all, we must understand what are the constraints, what are the rules, and what are the different keys in the relational database. So if we have this concept, then we can easily understand what is normalization in database and how we can normalize the tables. So what are the constraints? Constraints are the rules that we apply on different tables. That let's suppose if I say that if we have a specific registration number, we have, so this is how the data is stored in the form of the database in the table. So I think in the last lecture we have practically seen that too. So what are the constraints? Let's suppose I say that no one can enter a data in a column that is not a number. So we apply a specific check there. If the input data is a number or is an integer, then we can the DB operator can enter the data, otherwise they cannot. So that is the constraints, or that these are the rules that we use to apply. Now we have different keys on the basis of which we apply these constraints. So the first type of key is the super key. What are the keys? Keys are the attributes, the unique attributes which are used to identify that table or identify that column. So if you remember in the last lecture, we created different columns and a table in the Oracle database. So if we want to uniquely identify that columns, we assign them different keys. So we have first type of key, that is the super key. Now what is super key? Super keys are the attributes that can uniquely identify the complete row. Like for example, you are a student. Now as a student, if I have your registration number, let's suppose, then through your registration number, I can also know your what is your name, your father name, your class, your address. So this is how these things help. So what is super key? A type of attribute that can uniquely identify the other column. So that is a super key. Now the second type is the candidate key. Now what is the candidate key? So candidate key is a super key that contains no extra attribute. Like for example, in the super key we have the registration number. So in the super key we also have an extra attribute, that is the name. So it can be uniquely identify the other. But what does the super key do? Candidate key do that we don't need any additional attribute. Only the registration number is enough to identify that person. Then we have another type of key, that is the primary key. So a primary key is an attribute that is selected by the DB operator that can be used to uniquely identify the complete row. So if I talk about your primary key, then your registration, what is primary key? It is a attribute or a property that is very unique. Means that only that person on only that table contains that unique property. Like for example, your roll number. If your roll number is 203, then in your whole class there cannot be another student that holds the same roll number. So that is your primary key that uniquely identifies you as an individual. Like your, if I take another example, just like your registration number. So if you have a specific registration number, no other student can have that same registration number. So that registration number uniquely identifies you. So this is the candidate key. This is your primary key. So then, like here in this example, in the table, we write or identifies a column with the primary key like this. So here the registration number is your primary key, then the name, and we also have the class. Now we have the alternate key, means that can also a specific type of primary key that is not selected as a primary key. Like for example, roll number also can help you to uniquely identify yourself. Your registration number can also help you to uniquely identify yourself. But let's suppose that you select, or the DB operator select the registration number for primary key and left the roll number. Now here the roll number can place the role of the alternate key. So this is the alternate key. Then after that we have the composite primary key. Means here we used to combine two or more attributes together. Like we combine the roll number and the subject together so that they can make a primary key. Okay. Like for example, if you see that in the first column, roll number 1 is repeating 3 times, roll number 2 is repeating 3 times, and roll number 3 is also repeating 3 times. So we can say that our roll number here cannot uniquely identifies a person. So that's why we have to select or combine another column so that they both can uniquely identify as the table or the complete row. So if you see that roll number 1 and English, if we combine them both, we have no other combination of 1 and English. If we combine 1 and math, we have no other combination of 1 and math. So that's why when we don't have a specific primary key, so what we do we combine two columns, so such that that combination don't repeat itself. So that is the composite primary key. After that, we have the foreign key, means a type of keys that are used to refer as a reference in the other table. Like if you see that in the first table we have the primary key. So we use the primary key as a reference in the other table. So see, in the other table we have also the roll number, and in the first table we have also the roll number. So here the roll number is used as the primary key, or you can say that the composite primary key in the second table. So this is an example of composite primary. So these are the different keys that we use to learn in the relational database. Okay, so that was an important topic of keys, because before that, if you don't have a good understanding of key, we cannot learn the normalization. So if you have any question related to keys or relationships, let me know.
No, ma'am, it's clear. You can continue.
So now we have the normalization. So what is normalization? As in the above table, you have seen that the roll number 1 was repeating 2 or 3 times. Roll number 2 was also repeating the 2 or 3 times. So what does the normalization do? If we have a duplicated row, means a specific row is repeating multiple times, what the normalization will do? Normalization will eliminate that duplicated row. So basically, here the normalization is used to remove the duplication in that table. So this is the specific purpose of normalization. Now we have different types of normalization. We have different forms. We have the first normal form, we have the second normal form, we have the third normal. So here step by step we use this normal form to remove the duplication of data from the table. So first of all, we go with the first normal form, then with the second, then the third, and up to so on. So basically we have the that we mostly use, we normalize the table up to third normal form. So if we need, then we move towards the fourth normal form. So see, first of all, we have the, this is the sequence. We have the, first of all, the unnormalized table that contains the repeating group or repeating rows. Then we go towards the first normal form that removes that repeating group. Then we jump towards the second normal form that remove the partial dependencies. So what are these dependencies? We will study one by one. So these are the things that are going to be helpful in our normalization, in normalizing the table. So first of all, we have the functional dependency. So what does it mean? Means a specific value or attribute that depends upon the other. For example, the student name. So a student name here is completely dependent on a registration number. So if we have a registration number, then we can know the name of the student too. So here the registration number shows that here the student name shows that the student name is functionally completely dependent upon the registration number. If we have a registration number, then we can know the student name. Otherwise, we cannot know the name of the student. Then here in the expression, the left side of the column or the left column is known as the determinant. Okay. So what is a determinant? That identifies on which the a specific column is functionally dependent. So let's understand with examples one by one. So that is the concept of functional dependence. Now we are going to start the first normal. So in first normal form, our goal is that there cannot be a repeating group. Now what does it mean? It means that in each and every cell, there can only be one value. We cannot have more than one value in a specific cell. So if you see this table, now here, just see in the row second and the second cell of the row second. We have three values in one cell. So we have to remove this in the first normal form. See, we have here two values in a single cell. We have here three values. Then we have again three values. Here we have two values. Here we have two values. So in first normal form, what we try to do, we try to remove all of this. We have to make sure that each and every cell contains only one value. So first we have to remove this. So this is the condition of the first normal form, that there cannot be a repeating group. There can only be one value in a one or specific cell. So just like here. So now this table is completely in the first normal form. How? See, each and every value is in a single cell. Just like this. What we have do, we just remove the repetition. Means here, if you see that in the unnormalized table, here, the 21 contains, the 35 contains three values. So we assign 35 to the first one, this one too. Then we assign 35 to this two. And then we assign 35 to 204 and audit and 62. So we assign the accountant number to each and every column or cell values separately, so that we can easily normalize that table. So if we see this normalized table, see, so the 35 is assigned to all of the that repeating values. 35 is assigned to 130, to 179, to 204, to audits. So this is how we remove, we make sure that there is only one cell, one value in a specific cell. So what is our second goal? Our second goal in the first normal form is to normalize, is to assign a primary key to that specific table. So I told you what is a primary key. A primary key is the unique attribute that uniquely identifies the complete row in the table. Now here, if you see that the accountant number is repeating multiple times, but we need a specific attribute that uniquely identifies the complete row in the table. So here, what does the complete row means? So this is the complete row. So if you see, this is the complete row that we need to uniquely identify. So here we cannot use the accountant number alone as the primary. So what we do here, we use the composite primary key. So what is the composite primary key? I told you that when we combine two columns together in such a way that a specific combination is not repeating itself, so then it is the composite primary key. So when we here, just as in this example, combines the accountant number and skill number together, like we combine 21 and 13, so this combination is not repeating somewhere else in the table. So if you view, we have no other combination of 21 and 113. So it means that this is a unique combination. It can easily identify the complete this row in the table. Then we combine the 35 and 113. So this is how the primary key is made, or primary key is assigned to a specific table. So now this table is completely in the first normal form. We have the accountant number, skill number, and how they are related with the each other. So now, what is the problem with the first normal form? Why we need this second normal form? Now here, the problem is the updating problem. Now let's suppose the user wants to change the name of the accountant number 35. So here the accountant number 35, what is the name of accountant number 35? Let's see. It's Daud. But we want to change it from Daud to M Daud. So you can see that the accountant name Daud is repeating multiple times at multiple places. So we have to change this name at different places. So if we change it, so the 35 appears May in different records. So the updating can be very lengthy. It can be time consuming. Now it can also generate the inconsistent data. So we have seen that the content number 35 is repeating at three places. So what if we change the name at two places and forget to change the name at the third place? So what will happen? So it can produce the inconsistent data. Then we have the addition problem. Like suppose we have some users who want to add another skill number in their table. So we cannot change until we have the if that specific accountant with that skill exists. Because here the skill number and the accountant number both are using as a primary key. So that can be a problem here. After that, this is the problem with the first normal form. That's why we need the second normal form. So what is this second normal form says that? So here it says that a table can be in a second normal form if it's already in, it must be